Hi, I'm Steve Colby. Today I'm going to be talking about interfaces versus inheritance and when you should use them, when you should not. Okay, so first of all, we'll start looking at perhaps some of the differences between interfaces and inheritances and the pros and cons of them. So, what's good about inheritance? Well, we can inherit methods from superclasses. So we get the opportunity to push the methods up into the superclass. So it can save coding sometimes. We've got the Liskov substitution principle, which essentially says that if you have a class that requires another class to work, then you can substitute any of the subclasses of that second class. And they'll be substituted okay, and it works properly. So inheritance, when it's used wisely, it's a very powerful way of allowing you to manage your software. It gives you the ability to specialize particular classes, and the example I've quoted here is the gang of four state pattern, where instead of having a load of switch statements built into your classes, you just have an individual class for each of the states, and they're interchangeable because they all inherit from the same superclass. Okay. What are the bad parts about inheritance? Well, most languages don't support multiple inheritance, and that can mean that you can get some quite complex inheritance structures if you don't make use of interfaces. And so some of these deep complex hierarchies, they're quite difficult to maintain, because if you change something higher up the hierarchy, it's going to have a ripple effect on all of the subclasses, and if you don't have an automated testing scheme in place, it's going to cause you some severe problems when you're testing. Okay, so if we can just switch to another package. Here's an example of a complex inheritance hierarchy, and we'll just talk about a household appliance object. Now, we can see that that's been subclassed into electric appliance and gas appliance. And then below that, from the electric appliance, we can see we've got further subclasses of the 12-volt appliance, the mains appliance. And finally, we can see that a hairdryer, which is an actual kind of physical concrete class, is a subclass of mains appliance, which is a subclass of electric appliance, which is a subclass of household appliance. Now, things start to get a bit more complicated when you consider, say, a gas hob with electric ignition, because that would mean that we've got to make the choice further up the hierarchy. Is it an electric appliance or is it a gas appliance? And in this case, it's both. So what do we do? Unless we've got multiple inheritance, we can't really create a gas hob appliance, because we need it to be both, and we haven't got a class that works that way. So if we were to, we might go back and revisit the class structure, but then of course all the other classes that inherit from it would all have to be retested. So that makes it quite complex, quite brittle, and it introduces a big maintenance overhead. Right, let's go back to the presentation. So, what's a good thing about an interface? Well, we're only really specifying the minimal content of that interface, the contract that the object has to conform to. We're not specifying attributes, we're not specifying anything other than methods and the method signature. Okay? We're not supplying anything that happens to be in our class hierarchy that we don't need for the purposes of this interface. We can implement more than one interface. That gets us around the multiple inheritance problem, the one that we saw with the gas appliances that also have an electrical input, and makes it simpler. Kind of reduces the need for us to come up with a complex hierarchy, or even to extend existing objects that we don't really need, just so that we can conform to that hierarchy. The downside to interfaces, there's no implementation of those methods that you can inherit from. Okay, so that means you've got to provide your own implementation of them when you create a subclass or a class that implements an interface. You can't just inherit them from the superclass. And that's probably one of the only downsides. Now, there's a phrase which comes from the Ruby world, which is called duck typing. And the idea is that if an object walks like a duck and it quacks like a duck, then for all intents and purposes we can treat it as a duck. It doesn't matter if it has a whole load of other attributes and methods that we're not interested in. We're only interested in the ones that mean that it can conform to the interface specification. So we don't really care what the underlying type is. We can treat it as an object of type interface. In other words, the name of the interface. So if it's a gas appliance, we can say this is a gas appliance because it implements the gas appliance interface. We don't care about anything else. Okay. Here's a real world example of an interface that everybody knows. Okay, it's got 3 pins, 240 volts, alternating current, live, neutral and earth, and if you put more than 13 amps through it, it's going to blow a fuse somewhere. Now, that's an interface that's been around since 1947, so even longer than me. And the kinds of appliances that we have and that we plug into them have changed a lot. I mean, you can see here that the television looked a bit like a fishbowl in a wooden cabinet. And all sort of crass gender stereotyping aside, the washing machine that we can see in the picture here doesn't look anything remotely like the kind of washing machines that people use today. However, when the electrician put these sockets in my house, he had no clue what I would be using them for, whether I'd be plugging in an electric drill, my television, a kettle, or whatever. But as long as it conforms to the interface, I can plug anything into the socket and it will work. And the same principle applies here with software. As long as the object that we're creating conforms to the interface, we can use it. I say it's been around for nearly 70 years and it's still working. Since that interface was specified, the kinds of things that we can plug into the socket have changed dramatically. We've got PCs, we've got flat screens, mobile phones, even Alexa. I mean, in 1947, they couldn't even have comprehended the kinds of devices that we would be plugging into that simple interface. But it's still working because it's flexible and it's robust. If we look at a software example, and I'm using an example here from the Java world, you can implement what's called the comparable interface in your objects. And the comparable interface only defines one single method. So all you've got to do is say implements comparable, and then you define your method. It has to conform to the signature of that method as described in the interface, but apart from that, this gives you a whole load of information, a load of additional functionality, because, well, the Java framework makes extensive use of classes that implement comparable. So anywhere that you need to plug in a comparable object into the Java interface, you can, because those classes are built to expect that interface to be used. They don't care about all the other attributes and the methods that your objects might implement. All it cares about is does it implement the compare to interface, or does it implement the compare to method, and if so, I can treat it as a comparable object. And all of the collection classes, the sorted lists, the maps, sorted sets, sorting, sorted lists, anything, they all make use of comparable objects. So merely by implementing this one method in any of your objects, you can leverage all these classes, these very powerful classes that are already available in the Java framework. Okay, the Java framework classes all use interfaces extensively, and that should be a clue to you that you should be using them in your software too, because the guys who write Java probably know more about it than anybody else. So you can probably bet that if they're using classes, you should be using them too. Okay. Finally, just as a summary, superclasses, abstract classes, inheritance, they are very powerful tools, but you should probably kind of concentrate your efforts on making them fit your object hierarchy. Don't try to subclass other people's classes. Certainly don't try to subclass classes that are already part of the Java framework, because when they change in the future, as they inevitably will, you will have to retest all your software. So just use your superclasses, subclasses, abstract classes to define your own object hierarchy. Use interfaces to specify conformance. So you're not specifying an implementation, you're specifying a contract for that implementation. And because interfaces tend to be smaller and more focused, you don't end up implementing a load of methods that you don't need. But as we've already seen with the comparable class, it gives you a huge amount of extra functionality for very small effort on your part, because by making your object implement, say, the comparable interface or the hash interface or the equals interface, there's a lot of other functionality that you almost get for free without having to do very much work. Okay, well, I hope you've enjoyed this, and thank you very much.